Hello and welcome to our SOL review of A.02b, Polynomials. So what we're going to be focusing on is three topics of polynomials: adding, subtracting, multiplying, dividing. You might be thinking, wait a minute, that's two words for one topic, but they essentially go hand in hand. So in fact, let's start with add and subtract. So going back to the lesson from 8.1, we want to remember PEMDAS to see if there's anything we have to deal with inside the parentheses. But more importantly, before we even talk about that, we need to actually talk about what is a term. So a term is anything separated by addition or subtraction, and there's three parts to a term. So we have the leading number in front, also known as the coefficient. We have the little back part, which is known as the variable, and you can have more than one variable. It doesn't have to be, just x or y. It could be AB or CF, whatever letter combination you want to use. You can even have multiple variables like ABCD, so you got to be careful. And this last little guy, if you remember from the last lesson, is an exponent. What we're focusing on with adding and subtracting is the coefficient and variable. That's really going to determine what we're doing with the different pieces. And I'm also going to try to use the terminology a lot, so just be listening for it. So, adding and subtracting. So what we want to do is, following PEMDAS rules, we want to look inside the parentheses to see if any of the variables match. Now, you have to be specific. What I mean by this is, x squared is not the same thing as x. If you wanted to change these to last names, you could think of this as like Garber Miller, and then this would just be Garber. So the hyphenated name is different than just the regular name. And you can think of 4 as just someone that goes by one name, like Rihanna or Pele. So you can't actually combine anything in there. There's no exponent to distribute, and deal with, I should say, and there's no number in front either. So you actually don't need these parentheses at all, so I'm going to go ahead and get rid of them. So 2x squared plus 3x minus 4. Now, we kind of run into a similar situation here. We got 5x minus 9x squared. Like we said, those are not the same because the exponent changes the variable, n plus 1. There's no exponent on the outside that we have to worry about. However, there is this pesky negative right there that we do need to deal with. And the way we deal with this is by distributing. Since it's on the outside of the parentheses, you've got to remember, you can't just have a negative floating out there. This is really negative 1. And with distributing, it's multiplying. So essentially what's going to happen is all the signs are going to flip. So this was positive 5x. You got to remember, the parentheses shielded it for a little bit. But since we're distributing, the negative is going to get in there. So positive 5 times a negative, this will become minus 5x. Negative 9x squared was already a negative, and a negative times a negative is positive, so it'll become positive 9x squared, and positive 1 is going to become minus 1. Now, going off of those terms, this is where the add and subtract really comes into play. We can only combine terms that have the same variables. So for instance, here we have 2x squared. Well, we can only combine it with anything else that says x squared, which would be 9x squared. Notice how I'm also grouping the sign in front of the number. You could think of this as like Mr. or Mrs. or Doctor. You would never call somebody by like Jonathan Vilma Doctor. It doesn't really sound right in our language, and it's the same thing with numbers. So the sign is kind of the introduction to what the number is. We have a couple other things we can group. We can do positive 3x, and we can do minus 5x. And if you notice, I'm using different symbols. This just kind of helps you later on when you go to combine things. You'll know, oh yeah, the circles go together, the squares go together. Now you might be thinking triangle, but instead I'm going to change it up, and I'm going to go ahead and use a cloud, because they're nice and fluffy. Okay. So what we're going to do is we're going to start with the variable that had the biggest exponent. That would be x squared. So I had 2x squared plus 9x squared. We're going to combine the coefficients using addition. So 2 plus 9 becomes 11. The variable, the last name, doesn't change. You can think of it like a family reunion where everybody's just gathered under one name. So this will become 11x squared. The only way that the variable would change is if we're multiplying, and we're going to get into that in a second. We have positive 3x plus, or I should say minus 5x. So positive 3 minus 5, that's going to be minus 2x. And again, nothing happens to the variable. It's just the last name, essentially. And then we have minus 4 minus 1, which would be minus 5. There's nothing else we can do to this, so that's our answer. Now, how is this different than multiplying? Well, when we multiply, you could think of it like doing the distributive property twice. So what we're going to do is we're going to take 2x right here, and we're going to go ahead and distribute it to 3y, and we're going to distribute it to negative 5x. So numbers are numbers. They're always going to do whatever you've known since 2nd grade and 3rd grade or kindergarten, whenever you really started learning about numbers. So 2 times 3, well, that's 6. X times y. They're not the same variable. So what we're going to do is they're just going to coexist next to each other, just like that. Then we're going to do 2x times negative 5x. So 2 times negative 5, we talked about this, numbers are numbers, so this will become minus 10. X times x, if you think back to our exponent unit, this will become x squared. Then what we're going to do is we're going to take the y, since we've already distributed 2x to everything, and we're going to distribute y as well. So that way everything gets distributed. So we've got y times 3y. Well, the number in front of y is 1. We don't really write it, it's not really necessary. But y times y would become y squared, and 3 times 1 is 3. So this will become 3y squared. And the last one we have to do is y times negative 5x. And again, 1 times negative 5 would be negative 5. And then x times y, they don't clean up, so we're just going to put them next to each other. And I talked about this earlier. Variables, you always want to start with the alphabet first. You know, x comes first, so it's in alphabetical order. There is one extra step we can do, and it actually involves adding and subtracting. We can put together 6xy along with negative 5xy. And since we're just adding or subtracting, we just do 6 minus 5, which is 1. So our answer, I'm going to start with negative 10x squared plus 3y squared plus, I'm not going to write the 1 because I don't actually have to. So I'm just going to put xy. Now, if you were to do that on your own scratch work, it's okay, but just know that it's a little bit more professional in the math community to not write the 1. You wouldn't be wrong necessarily, but it's just not the way it's really truly written. Now, as for this division, if you'll notice on the bottom, we only have one term. That's perfect, because what we can actually do is split this up into 2 different division problems. You can see it kind of looks like a heart almost. Well, unfortunately for you guys, we're breaking the heart up. So what's going to happen is this becomes 2 problems. We get 4x squared divided by 12x, and then we also get that minus sign that was right there, 8x divided by 12x. All you do is you reduce as much as you can. For instance, x squared and x, well, I can take out an x from both, and that leaves 1 up top. 4 divided by 12, that would become 1/3. I'm not going to write the 1, just like I was talking about. Minus 8 divided by 12, well, that cleans up to 2/3. And then x and x, well, they cancel out. So you're actually cleaned up. There it is. All right, so let's put this together in an SOL problem. So here we have an expression, and we're trying to figure out, well, which one's equivalent. We got a lot of cleaning up to do. If you notice, I see sets of parentheses. I'm going to look inside to see if there's anything I can do. No and no, x and y, different last names. And x and y, they're different variables, so we can't really combine them. So what we're going to do is we're going to take 1/6 over here, and we're going to distribute it to these 2 things. And over here, I'm going to take negative 1/8, and I'm going to distribute it to these 2 items. So what we're going to end up with is 1/6 of 30. Well, the only number that comes to my head is 5. And then 1/6 of negative 24 would be negative 4y. If you notice, the variables didn't disappear. They're still there. That's important. So like I've been talking about, numbers are numbers. They never change. Over here, I'm going to do negative 1/8 times 32, which would become negative 4x. And then I'm going to do negative 1/8 times negative 16. A negative times a negative is positive, and 1/8 of 16 is 2. So there we go. Now we can combine some things. We've got an x over here, and we've got an x over there. We've got a negative 4y there, and a positive 2y there. So let's see. 5 minus 4, well, that's just 1x. And then negative 4 plus 2 is minus 2y. And there's our answer. It's B. Thanks for watching.